Okay, welcome to the second meeting sa Physics 173, continuation to ng discussion natin ng circuits with DC sources. Today, we're going to discuss another type of circuit, which is called the bridge circuit, and then we'll also discuss a few theorems na ginagamit sa, few fundamental theorems na ginagamit sa electronics. Okay, that will be important later when you analyze circuits. Excuse me. Okay, so let's begin. Wait a second. Okay, so ang first circuit na pag-aaralan natin today is called a Wheatstone bridge. It's named after an electrical engineer called, well, ang engineer is Wheatstone, and he developed itong tawag dito, itong type ng circuit na ito, which is now basically used in many types of devices. So basically, ang Wheatstone bridge is a circuit that contains 4 resistors, okay, arranged in this manner. Okay, so 2 of them are in series. In this case, yung R1 tsaka yung R2 ay in series sa isa't isa. R1 tsaka R3 are in series. And then yung R2 tsaka R4 are also in series. But then itong series resistance na ito, tsaka itong series resistance na ito ay in parallel sa isa't isa. Okay, and then yung itong resistor circuit na ito is powered by a voltage source. Okay, and what's unique about this is that you are taking the output between this terminal, which we refer to as terminal A, and this terminal, terminal B. So the output is not with respect to ground, okay, but it's between these two terminals, okay, that connect these pair of resistors to each other. Okay, so yun yung unique dito sa Wheatstone bridge na ito. Okay, so okay, wait. Oops. Teka, may konting technical issues. See. Okay, so let's continue. So, tulad ng sinasabi ko kanina, yung output is taken across or between terminal A and terminal B. Now, if that output, okay, so yung output voltage is just the the voltage between A and B, terminal A and terminal B, or points A and B, if that output is equal to 0, sorry. Okay. If that output is equal to 0, then ibig sabihin, yung V1 at saka yung V2, so yung voltage across R1 at saka voltage across R2 is the same. V1 and V2, V1 is equal to V2. Furthermore, V3 at saka V4, voltage across R3 and voltage across R3, R4, excuse, is also the same. Okay, so in this case, since V1 is equal to V2 at saka V3 is equal to V4, we can write V1 over V3, which is the ratio, okay, between this and this, okay, to be equal to V2 over V4, which is the ratio between the voltage across this resistor and voltage across this resistor. Okay, and using Ohm's law, Okay, we get I1 R1 over I3 R3 is equal to I2 R2 divided by I4 R4. Okay, and I1 tsaka I3 is the same kasi in series lang sila sa isa't isa. Okay, and I2 and I4 is the same kasi in series din yung R2 tsaka R4 sa isa't isa. So this cancels out and we are left with the ratio R1 over R3 is equal to R2 over R4. Okay. Okay. So let's consider this example. Determine the value of Rx in the balanced bridge shown in figure 36. The bridge is balanced. V out is equal to 0 when RV is set at 1,200 ohms or 1.2 kilo ohms. Okay, if the bridge is balanced, and that means Rx over Rv is equal to R2 over R4. Okay, which means the Rx divided by 1.2 kilo ohms is equal to, okay, so divided by 1,200 ohms is equal to 150 ohms divided by 100 ohms. So we can easily get Rx to be equal to 1,200 ohms, 150 ohms divided by 100 ohms, or 1,800 ohms. Okay, so that's easy enough. Okay, now what about the unbalanced? What about when the output across A and B is not zero? Okay, this means that the Wheatstone bridge is unbalanced. Okay, so now we're talking about an unbalanced Wheatstone bridge. Okay, now in this case, kailangan natin kunin yung difference between A and B. So kunin you to get the difference, to get voltage output, we need to get V at point A minus V at point B. Okay, now if you take a closer look dito, okay, so let's go back to this figure, and i-erase ko lang konti. If you take a closer look here, you will find na this is a voltage divider circuit where the output is taken here. You'll also find that this circuit here, so itong branch na ito, at saka ito, without this, is also a voltage divider circuit, okay, na kung saan yung output is taken here. So this is point B, so that's VB, and this one is VA. So you're actually taking the difference, the output voltage is actually the difference between this point here, sa voltage divider circuit na ito, and this point here, sa voltage divider circuit na ito. Okay, so what we're going to do is to express VA in terms of, sige, gamitin natin ito, no? R1 and R3. So R1 over R1 plus R3 times yung source voltage, and then VB is expressed as R2, R3 pala tayo nag-output, and then dito R4. So dapat ito ay R3, and ito ay R4 over R2 plus R4 times Vs. So the output voltage ngayon is equal to VA minus VB, or equal to R3, R1 plus R3 minus R4, R2 plus R4 times Vs. Okay, now, saan natin ginagamit yung unbalanced Wheatstone bridge? Typically, ginagamit natin yan for different types of transducers. Ano ang ibig sabihin ng transducer? I mentioned transducer last meeting. Okay? And sinabi ko, ang transducer is any any device that converts one form of energy to electrical energy. Okay, like for example, yung microphone is a transducer because it converts mechanical energy, yung vibrations ng diaphragm, into electrical energy. Okay, yung tawag dito, yung CCD sensor sa camera nyo converts light signals into electrical signals. Okay, a thermistor, which is basically a thermometer, but it's an electronic thermometer. It converts temperature into electricity, okay, by measuring yung output voltage. So pwede tayo maglagay ng various types of transducers dyan to measure different types of parameters, like intensity of sound, intensity of light, and temperature. Okay, pwede ring pressure. Okay, so for that we need strain gauges and so on and so forth. Okay, so yung transducer na yan ay merong property na kung saan pag nagbago yung isang parameter, like for example, temperature, naman nag-change yung temperature, magbabago din yung resistance niya. Okay? So, sa microphone, pag nagbago yung amplitude ng vibration, bibigay siya ng iba't ibang voltage. Okay? So ganun nag-work yung transducer. Okay? Yung kung ano man yung mechanical property or thermal property ng isang system or ambient property, pressure, mga ganun, ng isang system that is converted to electricity, meron silang relationship. Okay, typically it's linear, but sometimes it's non-linear, minsan inverse pa yung relation. But the fact is, meron silang relationship between yung properties ng material at saka yung kanilang electrical output. And for that, we need a transducer. Okay, so consider natin itong example na ito. In this transducer, we have a thermistor. Okay, so makikita niyo dyan yung thermistor. Okay, thermistor is a type of transducer that measures electrical signal. And yung thermistor na yan has a property such that when the temperature changes, the voltage that gives out, or its resistance, also changes. Some thermistors have a linear or non-linear relation with the resistance, but some have inverse. In other words, pag linear, non-linear, pag tumaas yung resistance, pag tumaas yung temperature, tataas din yung resistance. Pero pag inverse, pag tumaas yung temperature, bababa yung resistance. Okay? In any case, nagbabago yung resistance depende sa tawag dito, value depende sa temperature. Okay, so dito, etong thermistor na ito, sabi dito sa problem, so determine the output voltage of the temperature measuring bridge circuit in figure 38. Okay, if the thermistor is exposed to a temperature of 50 degrees Celsius and its resistance at 25 degrees Celsius. Okay, so ang temperature niya is 50 degrees Celsius and its resistance at 25 degrees Celsius is 1 kilo ohm. So at temperature of 50 degrees Celsius, may iba siyang resistance. Yun yung aalamin natin dito. So yun yung kukunin natin. Makukuha din natin yun to get the output voltage. Assume the resistance of the thermistor decreases to 900 ohms at 50 degrees Celsius. So ito yung sinasabi ko, no? At 25 degrees Celsius, okay, yung thermistor has a resistance of 1 kilo ohm. And then 50 degrees Celsius, yung thermistor has a resistance of 900 ohms. So nag-decrease yung tawag dito yung resistance niya when the temperature increased. Okay? So ano yung output voltage ngayon dun sa bridge circuit? So meron tayong expression for the output voltage. At ang expression natin for the output voltage is VA minus VB. In this case, it's 1 okay, if the thermistor is exposed to a temperature of 50 degrees Celsius. Okay, so ang VA natin dito is R3 over R3 plus yung temperature plus yung resistance ng thermistor. Okay? Okay. And yung so this gives us 1 kilo ohm divided by, may source voltage pa dito na 12 volts. So this gives us ano to? R3 is 1 kilo ohm plus yung 900 ohms pag 25 degrees Celsius. Okay, times 12 volts. So yung VA at 25 degrees Celsius is equal to 6.32 volts. Okay, then yung VB is equal to R4 over R2 plus R4 times Bs is equal to 1 kilo ohm divided by 1 kilo ohm plus 1 kilo ohm times 12 volts. This gives us 6 volts. Okay, so at 25 degrees Celsius, VA minus VB is 0.32 volts. Sorry, mali. Hindi 25, kundi 50. 50 degrees Celsius. Kasi at 50 degrees Celsius, yung thermistor nasa resistance of 900 ohms. 50 degrees Celsius and 50 degrees Celsius. So yung ma-measure yung VA, output voltage is 0.32 volts. Okay, okay, if the temperature, so at 25 degrees Celsius, yung our thermistor is 1 kilo ohm. So it's actually, so that means that the bridge is balanced at 25 degrees Celsius. Okay? Okay. Now, ang isang kinaganda dito sa thermistor nito is that, or sa thermistor nito, or by using this circuit Wheatstone bridge, is that you can actually make a calibration curve. Okay, ano ibig sabihin ng calibration curve? It's the calibration curve for this type of thermometer. Okay, so itong buong system na yan, you can consider it as a thermometer, electronic thermometer, kasi kasama yung values nung resistance sa resistors sa bridge circuit. Okay, so at 25 degrees Celsius, halimbawa dito, 25 degrees Celsius, yung output voltage, so you're going to plot the output voltage with respect to temperature is 0. Okay, since the bridge is balanced. And at 50 degrees Celsius, your output voltage is 0.32. Okay, so you have this plot. And which means na halimbawa at 60 degrees Celsius, if you assume that this relationship is linear, then you can actually determine kung ano yung ina-expect nyo na output voltage dito. Okay? So, ang ibig ko sabihin is this. If you measure certain output voltage, di ba? So, nag-measure lang kayo dyan. Based on this calibration curve, you can determine kung ano yung temperature. So, if you measure a point 6.4 na ano na output voltage, okay, that means that it's 75 degrees Celsius kasi na-double siya from 25 to 50, naging 50 to 75. So that's 75 degrees Celsius. Typically, ang isang pinagbabasehan nyo na standard is 0 degrees Celsius. So, titignan nyo kung ano yung voltage at 0 degrees Celsius. Bakit? So, anong gagawin nyo dun? Ang gagawin nyo lang dun is kuha lang kayo ng batya, lagyan nyo, punuin nyo yun ng yelo, lagyan nyo ng tubig yung batya na yun na may yelo. Saka nyo ibabad yung thermistor. Okay. Then, i-assume nyo ngayon, or typically yung temperature na yan is 0 degrees Celsius. So, measure nyo yung voltage, ang makukuha nyo yung voltage yan, if this is the system that you're using, is as a negative voltage. So, you have a third data point, which is this, and then you have this data point, yung room temperature. Okay, tapos malalaman nyo na gamit itong calibration curve na ito, kung ano yung temperature, ambient temperature based on yung output na voltage. Okay, so that's how you make a tawag dito, an electronic thermometer gamit ang Wheatstone bridge. Okay, so that's just one of the many examples na pwede paggamitan itong type ng circuit na ito. Okay. Now, ang next, ang mga susunod na i-discuss natin ay mga theorems na fundamental theorems na ginagamit sa electronics. And the first theorem na i-discuss natin ay tinatawag na Thevenin's theorem. So basically, ang sinasabi lang ng theorem na ito is that any two-terminal device I mean two-terminal resistive circuit pala, sorry. Can be simplified or converted okay, to its equivalent Thevenin circuit. Okay, yung equivalent na Thevenin circuit consists of which consists of a Thevenin voltage source, VTH, and a Thevenin resistance, RTH. And that's what you see dito sa figure 40. So, any two-terminal resistive circuit ay pwede nyo i-convert, i-reduce into this type of circuit. Okay, so how do you do that? Okay, so first, we need to define kung ano yung Thevenin voltage. So, anong Thevenin voltage? You get the Thevenin voltage, okay, from the open circuit or no load voltage between two specified output terminals in the circuit. So, Thevenin voltage is the open circuit, in other words, no load voltage across or between two specified output terminals in the circuit. Okay, Basically, ang sinasabi lang nito is if you have a circuit and that circuit is connected to a load, you take a look at kung ano yung nakikita nung load na yon dun sa circuit. Okay? Explain ko yan a little bit while after I define kung ano yung Thevenin resistance. So yung Thevenin resistance, RTH, okay, is the total resistance appearing between two specified output terminals, okay, with all sources, meaning voltage sources, replaced by their internal resistances, okay, which typically for an ideal voltage source, ang internal resistance is 0. Okay, so let me explain this further. Okay, so halimbawa, meron kang electrical circuit dito. Doesn't matter kung ano yan. Then you have a load here. Okay, so ito yung load mo. Ang typical na example na ginagamit natin is sa cellphone, di ba? Mobile phone, sina-charge mo yung mobile phone na yan. Okay, or yung laptop mo is the load when you connect your power output or yung power, yung source, yung voltage that provides electricity to the laptop. Okay, yung laptop na yan sees the charger. But yung laptop nyo na yan or yung mobile phone nyo na yan, it doesn't see kung ano yung mga individual resistances nung charger. Okay? It only sees yung effective resistance ng charger. That effective resistance is the Thevenin equivalent resistance. Okay? Wala siyang pakialam kung ano nangyayari sa loob. Ang pakialam niya lang is kung ano yung nakikita niya at that terminal, kung saan nakasaksak yung mobile device. In the same way, okay, yung laptop or mobile device ninyo, nakikita niya rin yung voltage between those two terminals kung saan sila nakasaksak. Wala siyang pakialam kung ano yung source voltage, kung ano yung voltage across each resistor or across each of the circuit elements. Ang nakikita niya lang na effective na voltage is yun nandun across between those two terminals. And that is the Thevenin voltage. And this is the reason kung bakit sobrang effective itong Thevenin equivalent circuit. Okay, because yung load, wala siyang pakialam kung anong nangyayari. Okay, wala siyang pakialam kung anong nangyayari dito sa loob, dun sa charger. Okay? Okay, so ito yung laptop ninyo or mobile device, di ba? Ang pakialam niya lang is kung ano yung nakukuha niyang voltage at kung ano yung resistance nung charger na yun. Effective resistance nung charger. Okay, so nakikita ng load yung Thevenin resistance and yung Thevenin voltage. Okay, so again, to get the Thevenin voltage, okay, you remove the load, okay, and then tignan mo kung ano yung voltage dito. And to get the Thevenin resistance, okay, again, you remove the load, but you replace the source with its internal resistance. And typically, yung internal resistance yan ay 0. Sometimes, or in reality, meron talagang internal resistance ang source voltages. Okay? So you replace this with its internal resistance. Then solve for kung ano yung nakikita na effective resistance between these two terminals. Okay, let's take a look at this simple example. Okay, again, we'll use the voltage divider circuit. So ito yung ating voltage source, ito yung isang resistor, tsaka ito pa yung pangalawang resistor. Okay, R1 and R2. So we're taking the voltage across R2. Okay, then we have this resistance R3. Okay, and meron kang, dito natin tinitake yung output, okay, nung tawag dito nung circuit. So supposedly merong load dyan. So dyan yung isasaksak yung, dyan yung ilalagay yung load circuit. Yung device ninyo has an internal resistance. So to solve for VTH, you remove the load, okay, and then tignan nyo kung ano yung voltage as seen by the load, okay, between these two terminals. In other words, kuha ka ng voltmeter, tignan mo, measure mo yung voltage dito. Yan yung VTH. Okay, ano ba yung voltage dyan ngayon? Now, between these two terminals, walang load, di ba? At dahil walang load, walang dumadaan na current sa R3. Okay? Kasi open to eh. Open. Diba? So dahil walang dumadaan na current sa R3, yung voltage dito ngayon ay 0 volts. So V3 is equal to 0 volts. So lahat ng current ay dumadaan dito. Okay, so now we just need to get kung ano yung volt. So VAB is just the same as V2. Okay? Wala tayong pakialam sa V3 kasi 0 naman yung voltage across R3. But V2, if you take a look, is nothing but yung output voltage at across R2, and you get that by recognizing that this is a voltage divider circuit. So yung Thevenin voltage ngayon, which is the voltage between these two terminals, is just equal to V2, the voltage across R2, which is just tawag dito, a voltage divider. So R2 over R1 plus R2 times Vs. Yun yung voltage divider equation natin, and that's also our Thevenin voltage. So alam na natin yung Thevenin voltage ngayon. Okay, so yan na yung Thevenin voltage. Now, how do we solve for the Thevenin resistance? To get the Thevenin resistance, okay, so again, this is open. Okay. Then we replace Vs by a short. So walang internal resistance. Dito sa example, no internal resistance, which means that we completely replace this voltage source by a short. Okay, now, ano ngayon yung effective resistance dito? So R1 and R2 are parallel, and then yung result ng circuit na yan, you add, ay magiging in series with R3. So the effective resistance is R3 plus R1 parallel R2. So R3 plus R1 parallel R2. Yan yung Thevenin resistance ngayon. At yun yung ilalagay nyo dyan. Okay, so ganun lang yung pag-simplify ng kahit anong circuit into a Thevenin circuit. Now, this process is called Thevenizing, okay, the circuit. So, dinedevenize nyo yung circuit. Okay. Okay. So, consider tayo ulit ng isang example. So, find the Thevenin equivalent circuit between the output terminals A and B, okay, of the circuit in figure 43. If there were load resistance connected across terminal A and B, would it first have to be removed? It would first have to be removed. Okay, so the Thevenin equivalent. So medyo straightforward na ito. Itong R2 tsaka R3 is 470 ohms plus 220 ohms. So that's 690 ohms. Okay, and so to get the Thevenin voltage, we recognize na ito ay voltage divider circuit, and walang voltage dito kasi walang open itong A and B, walang current na dumadaan dito sa R4. So we don't care about R4 dahil 0 yung voltage nga niya. So we only care about the output voltage here. So that's 690 ohms divided by 1 kilo ohm plus 690 ohms times N volts. Okay, that will give us 4.08 volts. Okay, so ang Thevenin resistance natin ngayon, okay, is ay makukuha natin if we replace this with the short, then we have R1, then we have R2 plus R3, tapos R4, and then we take yung nakikita na resistance, effective resistance between terminals A and B. Okay, so this is 1 kilo ohm, this is 690 ohms, and this is 1 kilo ohm. So we have 1 kilo ohm galing dito plus 690 ohms parallel to 1 kilo ohm. Okay, parallel itong dalawa na to sa isa't isa. Okay, and this gives us 1.41 kilo. So the effective Thevenin circuit ngayon, oops. So the Thevenin circuit ngayon is given by okay, so terminals A and B. So this is 1.41 kilo ohms and this is 4.08 volts. Okay, so yun yung Thevenin equivalent. Okay, so tulad nung yung discuss natin kanina, nagde-depend yung Thevenin voltage at Thevenin resistance sa kung ano yung nakikita ng load. If you put the load here, ano bang nakikita ng load na to? Ang nakikita niya is kung ano yung output voltage dito at yung effective resistance dito kapag ito ay sinort niyo. Okay, kung walang internal resistance ng source voltage. Okay, if you can also solve for the Thevenin voltage here kung dito nyo ilalagay yung load. Okay, so you take the output here, okay, to get the Thevenin voltage, and then short nyo to, then you get the effective resistance with respect to with respect to A and B, okay, between across R and R2. Okay, so the Thevenin voltage depends on where you look at. So, halimbawa, dito sa figure 46, okay, if we take a look at A and C, then yung Thevenin voltage is taken between terminals connecting R2 to R1 and then R3 to the ground. Okay, so this is nothing but a voltage divider circuit. So yung Thevenin voltage is R2 plus R3 over R1 plus R2 plus R3. Okay, times yung source voltage. Okay, and then yung equivalent na resistance, yung Thevenin resistance niyan is when you short this, ano yung resistance niya dito? Okay, if you short that, then R1 will be parallel to R2 plus R3. Okay, so R1 is parallel to R2 plus R3, and that's your Thevenin resistance. Now, if you want to get the Thevenin equivalent circuit between B and C, then you're looking at the terminals, kung ano nangyayari dito. Okay, in that case, yung Thevenin voltage is just R3, okay, divided by R1 plus R2 plus R3 times yung source voltage. So makikita nyo, ibang-iba yung expression, di ba? Depende kung saan nga kayo tumitingin. And kung dito nyo naman titignan yung kung dito kayo tumitingin ng Thevenin equivalent, so you're just taking a look at R3, this means na ang mag-series dito is yung R1 tsaka R2 at yung series na R1 tsaka R2 ay parallel sa R3. So R3 is parallel to R1 plus R2 and that's your Thevenin resistance. And it's entirely different, okay, from when you are looking at the terminals between A and C. Okay, so Yun, I hope clear yun, ano? And again, kung may questions kayo, just record yung timestamp nung question niyo or take a screenshot and then i-send nyo sa akin via email yung question niyo. And pwede rin tayong mag-Zoom if you think that mas kailangan niyo ng extensive explanation. Okay, so consider natin tong example na ito. So example 17, determine the equivalent circuit for the circuit in figure 47 viewed from terminals A, C. So dito at saka dyan. Okay, so and then sa letter B, viewed between B and C. Okay, so ibahin natin yung kulay. So between A and C, gamitin natin ay blue. So between A and C, okay, yan yung Thevenin voltage. Okay, so the Thevenin voltage between A and C, and that's just 4.7 kilo ohms plus 3.3 kilo ohms divided by 5.6 kilo ohms plus 4.7 kilo ohms plus 3.3 kilo ohms times 10 volts. Okay, this will give us 5.88 volts. Okay, letter A ito. And then ang RTH naman, okay, the Thevenin resistance is just makukuha natin yun by shorting the source, and then you have R1, and then you have R2 plus R3. So this is R2 plus R3. And then take the output here. This is R1. So what we're looking at is R1 R1 parallel to R2 plus R3. And yan ay magiging equal sa 3.29 kilo ohms. 3.29 kilo ohms. For letter B, yung kinukuha natin dito ay gamitin natin orange for letter B. Tinitignan natin kung ano yung Thevenin equivalent circuit dyan sa terminals B and C. So for letter B, yung VTH is VBC, which is equal to 3.3 kilo ohms divided by 5.6 kilo ohms plus 4.7 kilo ohms plus 3.3 kilo ohms times 10 volts. So yung Thevenin voltage dyan is 2.43 volts. Now yung RTH ngayon ay makukuha natin if we short the circuit, the source. Okay? And then we draw a voltage divider circuit na kung saan ito ay R3 kasi we're taking a look at yung Thevenin resistance at that resistor. And then itong nasa taas ay R1 plus R2. Okay, so the equivalent Thevenin resistance is R1 plus R2 parallel to R3. And this is equal to 2.5 kilo ohms. Okay. Okay. So now, ang i-Theveninize naman natin ay yung bridge circuit. So recall na ito yung ating bridge circuit. At tignan natin kung ano yung nakikita nung load resistance na ito, which means tignan natin kung ano yung equivalent na Thevenin voltage between points A and B. Kasi yun naman talaga yung output voltage, right? Okay, so anong gagawin natin? Siyempre, tatanggalin muna natin yung load resistance. Diba? Then we can see that we can redraw yung circuit into this. Okay? Pagkatapos, kunin natin yung Thevenin voltage. Sinolve natin yung output voltage between A and B before, at ito yung nakuha natin. Okay? So, nagawa na natin yung before, few slides before. Yan. Okay? So, Okay. Ngayon, kunin natin yung resistance. Okay, so Thevenin resistance. So gagawin natin is itong source na ito ay short natin. Okay, tapos tignan natin kung ano yung resistance between A and B. Okay, now this is a bit tricky kasi kailangan natin i-redraw itong circuit na ito. So kailangan natin bantayan yan, ano? Okay, so you're taking a look at A and B. Now R1 is connected, isang terminal ng R1 ay connected sa isang terminal ng R3. And isang terminal ng R2 ay connected sa isang terminal ng R4. Now, yung kabilang terminal ng R1 ay connected sa R2. Okay, and then yung kabilang terminal ng R3 ay connected sa R4. And this is actually a short. Okay, so, pwede nyo siyang i-redraw in this way. Kasi kung titignan nyo, R1 is connected to R3, but it's also connected to R2. So, R1 is connected to R3 and then connected din sa R2. Okay? Now, yung and then yung R3 connected sa R4. So itong R1 ay connected sa R2. Okay, and then yung R3 ay connected din sa R4. So actually, ito yung connection na yun. Okay, then itong R1 tsaka R3 ay connected sa terminal A. R1 tsaka R3 connected sa terminal A, and then yung R2 ay connected sa tsaka R4 connected sa terminal B. So ito yun. So ito ngayon yung equivalent na circuit nito. Okay? So, mas madali nitong i-compute kasi ang gagawin nyo lang, kunin nyo yung parallel nito, then kunin nyo yung parallel nito, and then makikita nyo na yung result is series nilang dalawa. Okay? So, the Thevenin resistance is just the parallel resistance of R1 and R3 added to the parallel resistance of R2 and R4. Okay? And yun na yung Thevenin resistance. Okay? Okay. Now, that's tawag dito, regardless of whether R1, whether the bridge is balanced or not. Okay. Okay, consider natin itong example na ito. Determine the voltage and current for the load resistance RL in the bridge circuit of figure 51. So to get the voltage AB, that's basically VTH. Dito ko siya isusulat sa baba kasi mukhang mahaba. VAB, so that's basically VTH. Okay, alam natin ang VTH is just R3 over R1 plus R3 minus R4 over R2 plus R4 times BS. Okay, so this will give us 680 ohms divided by 1010 ohms minus 560 ohms divided by 1240 ohms multiplied by 24 volts. Okay, so ang VAB ngayon or ang Thevenin voltage is 5.32 volts. Okay, now yung Thevenin resistance, okay, so base dun sa ano natin is that R1 is parallel to R3. Okay, R1 is parallel to R3 plus R2 is parallel to R4. So this gives us 1 over 330 ohms plus 1 over 680 ohms. Then you take the inverse of that plus 1 over 560 ohms plus 1 over 680 ohms. Then you take the inverse of that. So the Thevenin resistance is just 529 ohms. Okay, now ang pinapahanap dito is the voltage across the load voltage. So the load voltage is just 5.32 volts. That's your answer. Now, the current through the load resistor are L. Okay. Ano ngayon yung current through the load resistor? Wait. Sorry. Hindi yan yung load, hindi yan yung voltage to the through the load. Okay, so ganito yun explain natin. Okay, so you have this Thevenin voltage and you have this Thevenin resistance. Okay, so ito yung VTH, ito yung RTH. And you have this load. Yan, dapat ganyan na pag-load. Okay, so ano ngayon yung current, yung voltage across RL? So we need to get first yung voltage across RTH, okay, to get the voltage across RL. Now RL is 1 kilo ohm. So yung current through RL, okay, is just the Thevenin voltage divided by the Thevenin resistance plus RL. Okay, and Thevenin voltage is 5.32 volts divided by Thevenin resistance, which is 529 ohms plus 1.01 kilo ohms. So the current is 3.48 milliamperes. So that's the current going through the load. Now yung voltage across the load is just the current times the load resistance. So 348 milliamperes times the load resistance, which is 1 kilo ohm. So that's 3.48 volts. Okay? So, yan yung voltage across the load, tsaka yung voltage, tawag dito, current through the load. Okay. 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 Next na i-discuss natin ay yung concept na tinatawag na maximum power transfer theorem. Okay. Now, you would think na pag meron kayong voltage source, okay, yung voltage na po provide ng electricity dun sa load. Okay. And nagpo-provide siya at a certain rate. At yung rate na yon ng pag-provide niya is yung basically yung power. Okay? But the thing is, kung titignan nyo rito sa example na ito, yung RTH, yung Thevenin resistance, is not the same as the load resistance. Okay? And so the power, tawag dito, the rate at which electricity is delivered to the load, okay, is not actually maximized. Okay, bakit hindi siya maximize? Kasi ang sinasabi sa maximum power transfer theorem is that you transfer the maximum power, okay, when the load resistance, okay, is equal to the internal source resistance. So the maximum power is transferred from a source to a load when the load resistance is equal to the internal source resistance. So that's the internal source resistance. And in this case, okay, or not in this case, but in general, yung Thevenin circuit nyo provides the load voltage, the source voltage, and the internal resistance. Okay, so yung RTH is the internal resistance. Okay, tulad nung pinapaliwanag ko kanina, if you have a a load, yung mobile phone ninyo, it sees yung charger as delivering a certain amount of power, but it also sees the charger as having some resistance. So yun yung nakikita ng load na internal resistance ng charger nyo. Okay? Nagpo-provide siya ng this amount of voltage, VTH, but it also has an internal resistance which is just the Thevenin resistance. Okay? So yun yung titignan natin ngayon dito sa ano na to, sa example na ito. So, dito sa example, let's consider a load which tawag dito, which varies in resistance. So meron kang potentiometer dyan. Okay. So you vary the potentiometer such that the load resistance is 0, 25, 50, 75, 100, and 125. And titignan natin yung power, okay, delivered to the load. Okay, power across the load resistance. So let's see. Now for letter A, okay, now yung load resistance is 0 ohms. Okay, yung current is given by, okay, so in general, ang current is given by V sub S divided by R sub S plus R sub L. Okay, so yung current in this case is 10 volts divided by 75 ohms plus kung ano man yung R sub L. So for letter A, it's 10 volts over 75 ohms, which is 133 milliamperes. Now, yung power is just I squared RL. Okay, so that means it's, well, here, yung power is equal to, tawag dito, 0 watts. Kasi bakit 0? Kasi yung RL is 0. Okay. So for letter B, ang RL is 25 ohms. So ang current is 10 volts divided by 75 ohms plus 25 ohms. So this gives us 10 or 100 milliamperes. At ang power dito is 100 milliampere squared times 25 ohms. Okay, so ang power is equal to 250 milliwatts. Letter C, RL is 50 ohms. Current is 10 volts divided by 75 ohms plus 50 ohms. This gives us 320 milliwatts. And yung power is 300 milliamperes. 320 milliamperes squared times 50 ohms. So power is equal to sorry, hindi 320, 80. 80 milliamperes. So power is 80 milliamperes squared times 50 ohms. And this gives us 320 milliwatts. Letter D, RL is equal to 75 ohms. Okay, and yung current ngayon is 10 volts divided by 75 ohms plus 75 ohms. This gives us 66.7 milliamperes. So yung power is 66.7 milliamperes squared times 75 ohms, which is equal to 334 milliwatts. Okay, hindi ko alam kung naglagay ako ng additional slide dito. Okay, hindi ako naglagay. So, lagay tayo ngayon. Letter E. So, ang RL dito is 100 ohms. Okay, so ang current is 10 volts divided by 75 ohms plus 100 ohms. This gives us 57.1 milliampere, and ang power is 57.1 milliampere squared times 100 ohms, or ang power is 326 milliwatts. And finally, yung load resistance na 125 ohms. Yung current is 10 volts divided by 75 ohms plus 125 ohms. This gives us 50 milliamperes. So yung power is 50 milliamperes squared, 125 ohms. So power is 313 milliwatts. Okay. Now, if you graph that, you'll end up with this. Okay. This is a graph of the power, okay, across the load, power through the load resistance, okay, as a function of the load resistance. Okay. And basically, anong nakikita natin dito? Nakikita natin na meron siyang maximum power. Kailan maximum yung power? It's when the load resistance is equal to the source resistance. So yung source resistance is 75 ohms, and we get the maximum when the load resistance, okay, is 75 ohms. So that's 334 milliwatts. So this is what the maximum power transfer theorem is telling us. Okay, na you get the maximum power transferred if the load resistance is the same as the internal resistance of the system. Now, anong significance nito? When you're designing a circuit, you have to factor in kung ano yung resistance ng inyong load. Okay, so dapat magma-match yan. So that's called impedance matching. Okay, impedance is just another fancy term for resistance. Okay, pero well, i-discuss natin yan later on. Okay, so when the source is impedance matched with the load, then you get maximum power transferred. Walang gaanong nasasayang, okay, na current, okay, or na energy. Okay. Ibig sabihin, to design a circuit, you have to consider muna kung ano yung load resistance. Now, sa charging, okay, di ba sa charging, how do you design a charger, for example? Kailangan muna alam mo muna yung load resistance ng mobile device mo. You know, how do you get the internal resistance or the load resistance? Well, sa mobile phone, tanggalin mo yung battery nung tawag dito, nung mobile device mo, kuha ka ng multimeter at i-measure mo yung resistance across the two terminals. So that's the internal resistance and that of the phone, or that's the load resistance. Okay. Sa laptops, isasaksak niyo yung dalawang terminals ng multimeter nyo dun sa point kung saan sinasaksak yung power source. Okay. At i-measure niyo yung resistance doon, then you get the load resistance of your device. And that load resistance has to match with the Thevenin resistance, diba? Or the internal resistance of the system to get a maximum power transferred from the source to the load. Okay. Okay. So one more concept. Then we're done for today. Okay, so this concept or this theorem is called the superposition theorem. Okay, ano ang superposition theorem? So basically, sige, the current in any branch, in any given branch of a multiple source linear circuit can be found by determining the currents in that particular branch produced by each source acting alone. Okay. Okay, with all other sources replaced by their internal resistances. The total current in that branch, so the total current in that branch is the algebraic sum of the individual source currents in that branch. Okay, so naintindihan niyo ba? So current in any given branch, okay, of a multiple source linear circuit, okay, can be found by determining the currents in that particular branch produced by each source acting alone with all other sources replaced by their internal resistance. So if you have a circuit na multiple source, tulad sa example nito, dalawa yung voltage sources. Okay, you can find the currents passing through a branch. Okay, so example, ang branch na titignan natin na yung R2. By first shorting yung isang source with the internal resistance, solve for the current, okay, dun sa branch na yun. Then you short the other source with its internal resistance, and then solve for the current in that same branch. So the total current is the sum of the individual currents na sinolve mo dun sa branch na yun. Okay. So tignan natin dito sa illustration. Ito yung current, ito yung circuit na i-analyze natin. And we want to look at the current, the total current through R2, okay, based on these multiple sources. So, ang gagawin muna natin is i-short natin yung BS2 with its internal resistance. So, if the internal resistance is 0, then it's simply a short. Now, we solve for the current through R2. Okay? So, pag na-solve na natin yung current through R2, okay, that's easily solvable kasi this total current, okay, total current, saan na ba yun? Medyo maliit yung space, no? The total current is equal to VS1 divided by, okay, R1, kasi R1 plus, parallel yung R2 tsaka R3, di ba? R2 parallel to R3. Okay, so yan yung total na current. Okay, then, ang gagawin nyo is, isa-solve nyo yung, tawag dito, B2. Solve for, ayan, B2. Sinolve niya yung total current. So, ito yon. Okay. And then solve for V2 or ITS2. Okay, pwede rin naman yan. Okay, kasi voltage divider siya, di ba? Okay. So solve for V2. Okay, so V2 is equal to R2 parallel R3 divided by R1 plus R2 parallel R3 times VS1. Okay, once you get V2, I2 is simply V2 divided by R2. Okay, so yun yung I2 pag sinort nyo itong BS2. Okay, you'll end up with this expression. Okay. Now, next step is ito naman yung i-short nyo BS1. So you short this with its internal resistance. And makikita nyo na this is another voltage divided circuit. So in this case, ang IT is VS2 divided by R3 plus R2 parallel R1. Okay, so yan yung IT dyan. And then you solve for V2, okay, which is equal to tawag dito, sorry, just the voltage divider circuit. R2 parallel R1 over R3 plus R1 parallel R2 times VS2. Then you get I2 from V2 over R2. Okay. That's the I2 that you get by shorting this one. So I2 1 ito, I2 2 ito. So that means that yung total voltage is just the sum of this and the sum of this. So I2 1 plus I2 2. Okay, and that's what basically superposition theorem tells us. Okay, if you have multiple sources, short mo muna yung isa, solve for the current through a branch that you're particularly interested in. And short mo yung pangalawa, and solve for the current through that same branch. And then yung sum ng currents through that branch is the total current, okay, when the two sources are available. Okay. Okay, so consider natin tong example na ito. Use the superposition theorem to find the current through R2 and voltage across it in figure 8. Okay, so short muna natin yung BS2 if BS2 is shorted, then we get ano bang ginamit nilang notation dito? I2 S1. Okay, so I2 S1. I2 S1 is just equal to 10 volts divided by 100 ohms plus 220 ohms parallel 330 ohms, right? Kasi itong dalawa parallel, the short na to. Okay, and then you have this voltage divider equation times 100 ohms. And then, sorry, current nga pala yung inaano natin nila. Current yung solve. Okay, so ano yung current dyan? Yung current dyan is 43.1 milliamperes. Okay, and then we get tawag dito. We can get hindi yan I2 S1, total current yan. Total current. Then I2 S1 is equal to voltage divider. Okay, so medyo complicated yung ano na yun. Pwede naman natin gamitin ito. This is actually a current divider expression. Okay. So R3 over R2 plus R3. So times yung total current, 330 ohms, 220 ohms plus 330 ohms times yung total current na 43.1 milliamperes equals to 25.9 milliamperes. Okay, if you want, you can still use yung you can solve for V2, which is just anong tawag dito? 220 ohms parallel to 330 ohms divided by 100 ohms plus 220 ohms parallel to 330 ohms times 10 volts, and then divide everything by 220 ohms. So I2S1 is equal to this. Okay, lahat yan divided by 220 ohms. I2S1. Okay, and you'll still get 25.9 milliamperes. Okay, now, if we short VS1, then we get, for the total current, be 10 volts divided by, so ito ngayong R1 at R2 ay parallel. Okay, so 330 ohms plus 100 ohms parallel to 220 ohms. Okay, and for that, you get 399, 12.5 milliamperes. And you get I2S2. Okay, if you so first you get the tawag dito, use the voltage divider expression, 220 ohms parallel to 100 ohms divided by 330 ohms plus 220 ohms parallel to 100 ohms times 5 volts, and then divide everything by 220 ohms, and that will be I2 S1 S2. Okay, and I2S2 will be equal to 12.5 milliamperes. So the total current is therefore 25.9 milliamperes and 12.5 milliamperes, which is equal to 29.8 milliamperes. Now, tinatanong ko ano yung voltage across it. Okay, so very simply, the voltage across R2 is just 29.8 milliamperes, sorry, naghang, times 220 ohms, okay, which is 6.56 volts. Okay. Okay. And one more example pa. Okay, find total current through and voltage across R3. Okay. Now, it may look like na itong circuit na to is different from this. But if you analyze it carefully, pareho lang sila. Okay. So, you can redraw this. Okay, pwede mong i-redraw yan as, so, ito yung 20 volts. And then yan yung 1 kilo ohm. That's R1. Tapos, meron ka pang resistance dito, which is yung isa pang 1 kilo ohm. That's R2. And then yung voltage source. Okay, which is 15 volts. And then ito yung R3, which is 2.2 kilo ohms. Now, kung tatanungin niyo siguro, bakit yung 1 kilo ohm na ito, na resistor, ay nandoon naman sa ground? Well, ito ang tanong ko sa inyo pabalik. Nagba-matter ba kung nandito yung 1 kilo ohm resistor or kung nandito yung 1 kilo ohm resistor? Hindi, di ba? Kasi, it's still, tawag dito, it's still has the same current passing through it, regardless kung nandito siya or nandun siya. Okay? So, yan yung equivalent na circuit niya pag niredraw nito. Okay. So, what we're going to do now here is to short first this branch and then solve for yung current through R3. Okay, so using yung ating voltage divider circuit, we get the total current to be, okay, if this is shorted, then the total current is 20 volts divided by 1 kilo ohm plus 2.2 kilo ohm parallel to 1 kilo ohm. Okay, this gives us 11.8 milliamperes. And then yung I3, where the source 1 is not shorted, source 1 is present, is given by 2.2 kilo ohms parallel to 1.0 kilo ohm divided by 1.0 kilo ohm plus 2.2 kilo ohm parallel to 1.0 kilo ohm times 20 volts. So this is the voltage divider, okay, divided by 2.2 kilo ohms. Okay, so this results to 3.69 milliamperes. Okay, now if we short this, ano naman yung total current? Ang total current is then, if this is shorted, then these two are parallel. Okay, so the total current is then 15 volts divided by 1 kilo ohm plus 2.2 kilo ohms parallel to 1 kilo ohm. Okay, yung total current dyan ay 8.88 milliamperes. And then yung current through R3, kung switch 2 ay present, is equal to, so yung voltage divider natin is R3 tsaka 1. So, 3 kilo ohms parallel to 1 kilo ohm. 2.2, sorry. 2.2 kilo ohms parallel to 1 kilo ohm divided by 1 kilo ohm plus 2.2 kilo ohms parallel to 1 kilo ohm times 15 volts divided by 2.2 kilo ohms. And that gives us a 2.78 milliamperes. Okay, wait a second. Wait a second. Okay. Meron akong mali na na-drawing dito. Ano yung mali na yun? Okay. Ang mali is this. Baliktad. Okay, kung titignan nyo, itong VS1 is paganyan. Negative to positive paganyan facing the junction. And then yung VS2 is paganito, away from the junction yung negative to positive. So kung ito yung junction na pinag-uusapan natin, so dapat ito ay paganyan. Okay, what this results to is that the current through R3 na nasa-solve dito sa IS2 is negative. So this one is negative. So the total current is actually 3.69 milliamperes plus negative 2.78 milliamperes, which is equal to 910 microamperes. So the voltage across R3 is 910 microamperes times 2.2 kilo ohms. And this gives us about 2 volts. Okay. Okay. So, I realized that this maybe a lot to take in. So again, I encourage you to to answer some of these problems. Okay, and I also highly encourage you to ask questions regarding the lesson. Okay, I know na medyo difficult ngayon kasi naka-asynchronous tayo. But you can always ask your questions through email, and maybe we'll find time to answer your questions then during our laboratory classes. Okay. So this is it for now, and I will see you sa next na meeting.